today's lesson is double number line diagrams and tape diagrams. So these two things should be new because they are new totally to North Carolina curriculum. They are part of the Common Core, and it's another way to do ratios. So I'm putting them both together. I'm going to abbreviate. Double number line diagrams, double number line diagram. And what it is it's two number lines. You use ratios. You have to use multiplication and division. Multiplication and division. Addition and subtraction is a no-no. No addition and subtraction. Can you come back later? Hold on. Mr. Hornay, I'm recording. Can you come back?
Okay.
Thank you.
Yeah.
Okay. Sorry. Like I said, only multiplication, addition, subtraction is a no-no. And then you're going to find equivalent ratios. Equivalent ratios with a double number line diagram. A tape diagram over here, you use rectangle parts. It may look similar to like fraction bars, but you use rectangle parts. You also use ratios, multiplication, division, good. And then you're going to answer some questions about tape diagrams. Tape diagrams kind of give you an overall view. So there's a little something about double number line diagrams, double number lines, and tape diagrams. All right, so example 1, Miss George runs 10 meters in 4 seconds. So Miss George went running, and she ran 10 meters in 4 seconds. So we're going to use a double number line diagram, double number line diagram to find equivalent ratios. So here's how you start. To start it, you draw two number lines. So draw two number lines, put arrows on the end. One of them is meters and one of them is seconds. And then what you do is you take the ratio that I gave you. So look back in the problem, and the ratio I gave you was 10 meters in 4 seconds. So we start in the middle, we do 10 meters in 4 seconds. So that's how you start it. Double number lines, ratio. Now we're just going to use multiplication and division. So let's just start with something easy. If Miss George ran 0 meters, it would take her 0 seconds, right? So 0, 0. Now let's cut this in half. Let's say she ran, instead of 4 seconds, all I'm doing is I'm cutting it in half. She ran 2 seconds. So in 2 seconds, how many meters do you think she ran? 5, because I divided that by 2. It's the same set of ratios over again. So now let's come over here and let's double it. 4 times 2. So instead of running 4 seconds, she ran 8 seconds. And you have to do the same thing on the top. Double it. 10 times 2 would be 20. And then you can even do it again. Let's say this is tripled. So let's say she wants to run 30 meters. You can go the other way. 30 meters would be equivalent to what? How many seconds? So 10 times 3. 10 times 3 is 30. So 4 times 3 is 12. So that is a very quick outline of a double number line diagram. But I see this note right here on the bottom. So you can also find the unit rate. The unit rate. So the unit rate would be right here in 1 second. In 1 second, how many meters can Miss George run in 1 second? So what did we do? We said 2 divided by 2 is 1. 2 divided by 2 is 1. So 5 divided by 2, what's half of 5? Anybody know half of 5? 2.5. And so that would be the unit rate. So you can find the unit rate using a double number line diagram. So example 2. Example 2. Pause it so you can write this down. Driving at a constant, this word constant is important. Driving at a constant speed, you drove 14 miles in 20 minutes. So there is our ratio. On a double number line diagram, show equivalent ratios of the same speed. So I already have set up for you a double number line diagram, miles and minutes. And as you can see, here is my first ratio, 14 miles to 20 minutes. It's my first ratio. Also, if you drive 0 minutes, you're going to drive 0 miles, so 0 to 0. So let's find some equivalent ratios. The easiest thing to do is to just half it and double it. So let's half it. Half of 20 is 10. Half of 14 is 7. So that means in 10 minutes, we can drive 7 miles. So now, let's double it. So 20 times 2 would be 40, and 14 times 2 would be 28. Right? So that means in 40 minutes, we would go 28 miles. So do you see this one that I left blank here? I left blank. Let's figure out, see we have 10, 0, 10, 20, 40, so this would be 30. Now, does 20 go into 30 easily? No, there's not really a factor. I mean, there is one, but it's not a nice scale factor. So instead of using 20, let's use 10. Does 10 go into 30 easily? Yes. 10 times 3 would be 30. 10 times 3. So then we would have to do 7 times 3, and that would be 21. So again, this is a double number line diagram, and they are equivalent ratios. 7 to 10, 14 to 20, 21 to 30, 28 to 40. Equivalent ratios. Okay. So you try number 3. Use a double number line diagram to fill in the blanks. This one is about blue squares to yellow squares. And, ooh, that smells. Mr. Klein gave me, ooh, a smelly marker. So I want you to fill in the blanks. Here is a blank, and here is a blank. And then we have blank, blank, blank. First thing to do is find the ratio. What did I give you that is the ratio? Alright, so here's the ratio. 25 blue to 20 yellow. So now you need to use that ratio to fill in these blanks. You work on this, pause it, and then press play when you're ready for me to show you. Alright, ready? So the first thing to do is find your ratio, 25 to 20. And we need to go lower. So let's look and see if we can find anything that will be easily divided. Easily divided. Does 8 go into 20 easily? No. Does 15 go into 25 easily? No. Does 5 go into 25 easily? Yes. 5 will go into 25 5 times. So that means 25 divided by 5 is 5. So 20 divided by 5 would be 4. So that's your first one. That's the easy one. And now from there, you can use these or you can use these. So do you see the relationship between 4 and 8? That one should be easy to you. It doubled. 4 times 2 is 8. So 8 times 2 is 10. And then do you see another relationship? What about 10 to 15? Not very easy, but what about 5 to 15? Yes. 5 times 3 is 15. So 4 times 3 is 12. And now I have 2 blanks. Any idea what's going to go in those 2 blanks? Anybody? Let's see, we have 4 times 2, 4 times 3, 4 times 5, see, times 2, times 3, times 5. So using that pattern, what do you think is going to go here? 4 times 4, exactly. So this is 16, and 5 times 4 would be 20. So check your blanks to see if you got it right. 10 and 20 on top, 4, 12, and 16 on the bottom. All right. So example 4 is a tape diagram. It says the paint ratio, let's pretend we're going to paint, is 3 parts yellow to 2 parts blue. 3 parts yellow. I have to use the stinky yellow again. So 3 parts yellow. Now, if you don't have a yellow pen or marker, just put a Y. To 2 parts blue. So blue. And this is a tape diagram of the rectangles. So now we're going to use this tape diagram to answer some questions. So here we go. What's the total? How many parts do I have? I have 1, 2, 3, 4, 5 parts. So I have a total of 5. How much does each represent? So if I have a total of 5, that means each part represents 1/5. Because 1/5, 1/5, 1/5, 1/5, 1/5. I have a total of 5, and each part represents 1/5. If the tape diagram represents 5 cups, so this is equivalent now to 5 cups. Each part is, well, if this is equal to 5 cups, then each of these would be 1 cup. Because 5 divided by 5 is 1. 5 divided by 5 is 1. If the tape diagram represents 1 gallon, so all of this total would be 1 gallon. Each part is 1 divided by 5 is 1/5. So 1/5 of a gallon. So let me show you how I got that again. This whole thing represents 1 gallon. And it's 5 parts. So you would do 1 divided by 5 and you would get 1/5. So that's where I got 1/5 of the gallons. Alright, so example 5, to make oobleck. Hang on 1 second. Alright, to make oobleck, I think you made that in science. Use 2 parts cornstarch, so we're going to call that cornstarch, to 1 part water. So I want you to use the tape diagram to answer these questions. I have 3 questions for you. 2 parts cornstarch to 1 part water. Here are your 3 questions, and what I'm going to do is we are going to go over these tomorrow in class about the tape diagram. So how many total parts do you have right here? How many total parts? Each part represents how much? And then if we want to make 30 bags of oobleck, if you want to make 30 bags of oobleck, how much cornstarch do you need and how much water do you need? So if you want to make 30 bags, now this one, it might be helpful if you do a double number line diagram. It might be helpful unless you know how to solve it. So we're going to go over these in class tomorrow, and if you are questioning this, then look back at example 4 at my tape diagram.